Hello everyone. Today we are going to see about heap data structure. In this video we will cover the heap theory part. In next video we will be doing the code implementation in Python and Java. Let's get started with today's content. So what is a heap? Heap is a specialized tree-based data structure that follows some properties. So what are those properties? They are going to be our complete binary tree property and heap order property. So heap is a tree-based data structure. So then what is the difference between tree and a heap? The first difference is going to be heap is a complete binary tree. So complete binary tree. But what is meant by complete binary tree? Let's break this word into two parts. One is complete and another is going to be a binary tree. So what is a binary tree? In order to say a tree as a binary tree, it should have at max two children for each parent. This is going to be our parent and these two are going to be our children. If a parent have at max two children, either it can have zero children or one or two, then they are called a binary tree. So then what is mean by complete? In order to say a tree is a complete binary tree, it should follow two conditions. All levels should be filled. We can give exception to the last level. And while filling the level, we should fill the nodes from left to right. Example, let's say I am having five elements, one, two, three, four, and five. I'm going to create an binary tree for these five elements. If you see here, I'm keeping at max two children for each parent and I'm filling the nodes from left to right. This tree have three levels. This is my level 1, level 2 and level 3. My level 1 and level 2 are completely filled. Completely filled in the sense I have one parent and the two children are the level 2. I don't have anything left in my level 2 to get filled. Level 2 can hold at most 2 power n elements. Level 1 can hold at most 2 power 0 nodes. Level 3 can hold at most 2 power 2 nodes. In our case, we are left with two more empty nodes in the level 3, but we can give exception to the last level. Let me write another one example. Is this in binary tree? No. You may ask me a question. This is same like in this example. Then why it's not a complete binary tree? Here also level 1 is completely filled. Level 2 is completely filled. Level 3 is partially filled. You may ask me, we can give exception to the last level, then why it's not a complete binary tree? We can give exception to the last level in case of number of nodes. If you see here, the last node here is going to be 2, here is going to be 3. That's fine. But there is a one another property, like I mentioned before, we should fill the nodes from left to right. This property got violated here because if you see here, there is one missing node in this binary. So this is not going to be a complete binary. So we understood what is complete binarity. Complete binarity basically follows two conditions. All the levels should be filled. We can leave exception with the last level. While filling the nodes, we should fill the nodes from left to right. So we are done with the complete binarity. Let comes to the heap order property. So I'm just going to make a representation of the heap. This is going to be parent. This is going to be children. So in order to say a binary tree, I mean complete tree as heap, it should follow heap order property. What is going to be heap order property? My parent, either they can be smaller than both children, or my parent can be larger than both children. Example 5, 6, and 7. In this case, 5 is smaller than 6 and 2. In this case, 5 is greater than 1 and 2. Right? So this is going to be a heap order property. My parent, either they can be smaller than both the children, or they can be larger than both children. There are basically two types of heap: min heap and max heap. What is a min heap? In min heap, my parent will be smaller compared to children. If you see here, 10 is smaller than 20 and 30. Then what is a max heap? In max heap, my parent will be larger compared to a child. In max heap, the parent will be larger compared to the children. Use cases for heaps. Heaps are used in maps, I mean navigation systems, to find the shortest path. Heap-based data structure are used in our OS operating system to schedule the tasks based on their priority. Heap-based data structure are used to implement priority queues. We will be covering priority queues in detail in upcoming videos.